Welcome to math, where every solution just leads to more problems. I'm your host, Julia, and today we're going to delve into trigonometric functions. Yep, that's right. Sine, cosine, tangent. And no, they're not some weird indie bands. They're actually the backbone of triangles, circles, and basically everything cool in math and physics. Alright, let's start at the beginning. What even are trigonometric functions? At their core, trig functions are just ratios that relate the angles of a right triangle to the lengths of its sides. That's it. Fancy math talk for something that's actually super logical. The main ones that you'll hear a lot about are sine, cosine, and tangent. They exist because triangles are everywhere. I'm serious. Architects, engineers, video game designers, NASA, everyone is out here doing trig. Basically, trig functions help us connect angles and distances without having to physically measure everything. Picture a right triangle. One of the angles is 90 degrees and the other two are smaller angles we can work with. Let's focus on one of them and call it theta. Now, to figure out how the sides relate to that angle, we use something called SOHCAHTOA. It's a handy mnemonic to remember the definitions of the three main trig functions: sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. In each case, you're looking at the sides of the triangle in relation to the angle theta. The opposite side is across from theta, the adjacent side is next to theta, and the hypotenuse is the longest side, always opposite to the 90-degree angle. SOHCAHTOA helps you quickly remember which sides to use for each function. Okay, now let me show you an example. Let's say that we have a right triangle where we know one of the angles and we know the length of one side. Imagine we have a right triangle where this angle is 30 degrees, the adjacent side is 5 units, and we're trying to find the hypotenuse. With this, we know that we have an angle, the length of one of the sides, and its relation to the angle given. Since this side is adjacent to the angle, and we need to find the length of the hypotenuse, there's only one function that covers all bases here: cosine. Remember, cosine is adjacent over hypotenuse, so we set up the equation like this. Cosine of theta is equal to adjacent over hypotenuse. By plugging in the numbers, we get cosine of 30 is equal to 5 over hypotenuse. Now, to solve for the hypotenuse, we'll have to rearrange the equation. We can multiply both sides by the hypotenuse to get it out of the denominator. This would give us hypotenuse times the cosine of 30 equals to 5. Now, we divide both sides by cosine of 30, which gives us hypotenuse equal to 5 over the cosine of 30. If you pull out your calculator and calculate cosine of 30, you'll get about 0.866. Now, we have hypotenuse is equal to 5 over 0.866. When you divide 5 by 0.866, you get approximately 5.77. So, the length of the hypotenuse is about 5.77 units. And there you have it. We use the cosine function to find the hypotenuse in this triangle. If the length given was not adjacent to the angle, then we would need to use the sine or tangent functions depending on what information we had. By rearranging the equation, we can solve for the missing side, so depending on what side and angle you know, you just pick the right trig function and use it to find the missing piece. Okay, now it's your turn to do some math. Grab a calculator and pause the video when you need to, or just yell your answers at the screen like a game show. I won't judge. Imagine you're standing 20 feet away from a tree and you're looking up at the top. You measure the angle of elevation to the top of the tree and find it's 40 degrees. Now, you want to know the height of the tree. What do? Well, here we have an angle of 40 degrees, a side length, and its relation to the angle, and the side that we need to look for. If you look carefully, you'll see that the side length given is next to the angle, so this means we have the adjacent side length. We can also see how the height of the tree is opposite to the angle, so we know that what we need to find is the opposite side. Which of the trig functions would be best suited for this? In this case, it would be tangent, because tangent is opposite over adjacent. Writing out the equation, it would be tan of theta is opposite over adjacent. Substituting the values, it would be tan of 40 degrees is opposite, because this is the unknown value, over 20, which was the distance from the person to the tree. To solve for the height of the tree, we need to isolate opposite in the equation. To do this, we can just multiply 20 on both sides. This leaves us with something we can plug into our calculators. 20 times tan of 40 degrees. If you did it correctly, you should get that the height of the tree is approximately 16.78 feet. Next up, let's say you're standing next to a 10 feet tall lamppost and the angle formed from your feet to the top of the lamppost is 30 degrees. Let's say you want to find the distance from your feet to the top of the lamppost. How would we do that? Well, here we know that we have an angle of 30 degrees, an opposite side length of 10 feet, and the missing side length, which is the hypotenuse, as it is opposite from the 90-degree angle formed between the lamppost and the ground. With this, we can use the trig function of sine, since it is opposite over hypotenuse. Running it down, it would be sine of 30 degrees equal to 10 over the hypotenuse. To isolate the hypotenuse, we would need to multiply it on both sides of the equation to get it out of the denominator. Then, we would divide both sides by sine of 30, which would leave the hypotenuse equal to 10 over sine of 30. By plugging this into the calculator, you would get that the hypotenuse of this triangle, or in the context of the problem, the distance from your feet to the top of the lamppost, is 20 feet. See? Not so scary, right? Trigonometric functions are like your trusty toolkit for triangles. Whether you're dealing with heights, angles, or any situation where measurements get tricky, they're always going to be there for you. And remember, if you get stuck, just break it down and use SOHCAHTOA to figure out which sides to work with. Well, that's all for today. I hope you enjoyed this dive into the world of trig. Keep practicing, and soon you'll be solving triangles in your sleep. Or, maybe just in class. Until next time, bye!